But you can actually create fake Lagrange points if you use other technologies, and if you can move spacecraft closer to the sun and give you, double, for instance, we're talking about twice as close to the sun, giving you twice the capability. As far as the moon goes, there's just been a big study done. I thought I had a copy of it, and I was going to bring it. Basically, there was NASA put together a committee, and I've forgotten the name of it, to look at science you can do from the sun. And every component, earth scientists, astrophysicists, planetary scientists, solar scientists, contributed to that document and the kinds of science you can do. For us, you're seeing particles unaffected by the Earth's magnetic field, so we can actually study energetic particle acceleration and transport in the heliosphere without actually, astrophysics, anything when you imagine as you have an atmosphereless platform, but as Chris pointed out, you still have to launch all that mass there to build the telescope. Particle detectors are really small, and so you can actually see them unaffected by magnetic fields, at least the Earth's magnetic field. So there's a lot of science that's been proposed that could be done, assuming you were there, that's above and beyond looking for water and studying geology.
You can unwind a big wire cross dipoles and make a radio telescope that's just spectacular and get away from all the noise, both man-made and auroral, So a lunar farside would be great for a lot of detectors, gamma ray, almost any telescope plus radio. We've also done some radio sounding, active radio experiments where we bounce radio waves off of plasma structures. You can do that from the moon. You can use the lunar regolith to build some stuff. So if you had sent a robotic mission ahead of time to kind of start collecting your materials, it's possible you could think of ways that you can do that without shipping up as much material. And of course, the other option is to start from a space station rather than shipping, a giant lunar capsule full of stuff, but making a bunch of small missions and then assembling it at the space station and outside gravity. And then you'd have a much more efficient way of getting there.
So we still have some time left. It's 12:46. Does anyone have any questions?
Sure. So we're at solar minimum right now. Do you think in the next 10 years, due to more activity and having all these vulnerable satellites up there, do you think that space science is going to get kind of a push from private industry, from all the?
It is really funny. Somebody went back and did a plot of Sidney Chapman's publication list, and it matched the solar cycle precisely. When the sun gets active, a lot of science gets more interesting because things are more interesting on the sun, and certainly the more we put up space hardware, the more space weather is important to us. There was a recent. We just heard that because of a slight programming error that that sent out something to GPS that cell phone users were offline for like 2 days. They mentioned that at the meeting Monday. So there was a spacecraft failure in Canada and all the ATMs went down. You can imagine that has a tremendous financial news when something like that happens, and those are certainly more prevalent at solar maximum. Another interesting thing right now about the sun that we're kind of watching, I heard a great talk by Joan Feynman. Richard Feynman's sister is a space scientist at JPL, and she was talking about solar influences on climate. It's still very controversial because nobody has a really good mechanism, but in fact it's a very strong correlation, so something's happening that we don't understand. But fundamentally, we're in a situation where global warming is doing this, okay? But the sun is at a very, very deep minimum, so it puts a little perturbation, a little cooling perturbation on this Earth human-induced solar warming. And so everybody's saying, oh, solar climate change is fake. It's not real. And that's because you've got a small solar effect on top of the human effect. So I think these are the kinds of things when we see the sun coming back in 5 years, it's going to be really hot. So plan where you want to buy your vacation. I think you should, literally, you're at the age now you need to think about where you want to be. I would not be very close to the coast, and I would be a place that had good fresh water supply. But the other thing that's interesting about the solar influences on climate was the last time the sun was this quiet. We had like 3 years without sunspots. The last time we went 3 years without sunspots was in 1912 and 1915 when the Titanic sunk because there were so many icebergs. So there is a link between deep, long solar minimums. And the one thing that she brought in her talk was that, in fact, if you look at the solar velocity at the poles and the helium ratio, we may be moving into a more quieter solar period. I mean, the next maximum may not be as high. And so it's an interesting thing to be. It's a great time to be a solar physicist because there's a lot of things happening, some of which we know and some of which we don't know.
Yeah, this last solar minimum, some people, if you look at the conferences, the sessions of the conferences at the beginning, after about a year or so, it was the peculiar solar minimum, and everybody jumped on it. In fact, there's a special edition coming out, Solar Physics, at the end of the summer. And it was peculiar, and then I talked to some other people who said, actually, this is the only normal one we've had for several decades. If you look at the conferences after the second year, when it was still a minimum, it was an extended minimum, it became extended rather than peculiar. Because 1920 was, everybody talks about the Maunder minimum, but it was 1920s, 1912 to 1920, that period where it was low. The big thing is whether you can, we're coming out of it now, we actually have an M-class flare not that long ago, which is a fairly big flare. The big issue...
So when the activity that we predicted using our real-time monitors here at Rice.
So everything, I mean, what was unusual about this solar minimum was not what the sun did, but the fact that we had all these space-based resources and ground-based resources monitoring it. Solar wind measurements, field measurements, neutron monitors, observations of the sun, the works. And so everybody gets excited because we've never seen the sun like this before, only because we've never had the telescopes before, not because the sun didn't do it. But the point I was bringing up from what Pat said was that the issue is can you predict events and can you predict cycles? And that's this dichotomy between operational science and this weird phrase that's come up in the last couple of years called curiosity-driven science. If you guys are not doing science because you're curious, you should leave right now. But that's a phrase. That's a phrase in our field now is because the money's in the operational side, the interest is in the curiosity side, so we all, you're old enough, I can use this phrase, we prostitute ourselves to the operational side to get our science. To some extent, we all put the word space weather in the proposal, for example.
Try and do that in astrophysics.
Yeah, well, you've been prostituting yourself to planet finding. But it really is, there's a lot of science in trying to predict what is going to happen, what the influence of what the sun does on the Earth or the Earth's environment. So there really is an awful lot of science there in addition to how you turn it around. In terms of the solar maximum, that has all sorts to do with the dynamo problem, which has a lot to do with astrophysics and stellar activity, and so there's really a lot of really cool science that goes into that. I'm sitting in the middle between space science, between space science where the sun tells the Earth what to do, and these guys need to know about the sun, and astrophysics where we actually have an astrophysical object that we can study in great detail. So the sun rules, and we can feed into fundamental astrophysics as well as stuff. So it's really kind of interesting to see what's going on, and it's, as Pat said, it's actually quite a good time to be looking at the sun and seeing what's going on.
It's 12:53. I think we have time for one more, but if anyone needs to leave, then they can